So after overnight in the cold room, just bring those tubes in ice, and now we are going to use Zeva spin desalting columns. Those are a special kind of column. We can purify the big protein or protein conjugated molecules, small drug molecules. So these are the steps. So here I'm gonna show how to do that process. So first, take out the Java spin desalting columns and put column in the conical tube like falcon tube, and after that use the centrifuge machine to remove the solvent. For the centrifuge machine, RCF value should be the 1000 and time is 2 minutes. And now we are going to add the falcon tube in the centrifuge machine here, so you can see the machine, and here the tubes with the Java spin columns. So now I'm opening the centrifuge machine, and you see that like uh, this rotor can be opened like so. If you hold it and push it, then it will be like open it, and then you can put the proper case for the falcon tube having the Java spin column. So here, after removal of that, I will put the other the centrifuge tube container, and in that way, like I will put 1 pps buffer solvent in the column to like column, and I'll do the centrifuge like to wash out everything from the Java spin column, desalting column. And in the third step, like once third time is done, then I'll put my original that solution from the bioconjugation taken out from the cold room, and then I will do the centrifuge again, and I will collect that liquid in the falcon tube, and that will be my conjugated protein with the small drug molecule. So here I'm showing how to open this component from this centrifuge machine. So there is a special technique or like a screwdriver. So just by using that, then you can take out the things from the centrifuge machine to set up the proper tube container. So here I just removed one part, and now I'm going to add the container, like tube container, which is like good for the falcon tube to separate to do the centrifuge to separate the bioconjugated protein from the solution. So here this is one setup. So I have another component, so I'm gonna see, you can see that. So I'm gonna put this here, and I will fix it in the centrifuge machine. So it is easy, just there is a screwdriver, so just you have to put here and then rotate it, and it will be like getting tight. So once it is tight, then you can hold it, and now this is the Java spin column. So this bottom part can be snap out, like you can break down, and then you can put this Java spin column in the falcon tube. And so here I'm taking that Java spin column and breaking that bottom part, and now I am putting it in the falcon tube. And make sure that you keep the cap loose, not tight enough, loosen. And that Java spin column by default, like from the commercial source, have the liquid inside it. So the first time you can remove that liquid from this column by centrifuge. That means with the centrifuge machine, it will dry out the liquid, and that liquid will be deposited in this falcon tube. So again, I'm choosing another Java spin column and making a little loose here, and now I'll put in the centrifuge machine. And always remember that add two column in opposite direction so that the balance can be kept. So here now you can see how I kept those Java spin column. So you see that like just opposite of each other, so that the balance can be um, equilibrated during the rotation. So once it is kept like that, so in that case you can so you can go even like 4 columns together if you have good amount of the liquid. Then normally I go for the 4 of them, or even you can use 6 of them. So here I'm using 4 of them, but make sure that you label it properly in the falcon tube, like which one is what. In that case you wouldn't be confused which one was what. So here I'm using 4 of them for this specific separation of the bioconjugated protein. Now you can see like how I kept those tubes here. So opposite direction, just opposite direction. Now I'm going to close this centrifuge machine, and the value, it should be RCF, and it could be 1000, and the time should be 2 minutes, and temperature is kept 4 degrees Celsius. So here you can see 2 minutes, and also the RCF value should be changed to 1000. And here you can see the on the way left like RPMs and RCF, so you can change to RCF, and you can see that in the display also RCF. So I'm going to make it 1000 for this combination. So once the value is set like 2 minutes 4 degrees Celsius and 1000 RCF, then and all those tubes are kept there, I will click start, and it will start rotating. And before starting, making sure all the parameters are set accordingly. And now I'm pressing start, so it will be done within 2 minutes. And since the machine is showing new rotator is set installed, yes, because I changed the rotator, so machine detected that rotator. And now after 2 minutes the centrifuge will be done, and all the solvent from the column will be taken out. So here you can press open. So once it is done, so you can see the liquid in the bottom. And now I'm gonna throw out that liquid part, and then I will add more of the 1 ppb solution in each column. So the falcon tube, I just take out the falcon tube and I'm discarding the liquid, and in my that empty Java spin column I will add 1 ppb solution in all of them. And every time I will use all 4 of the Java spin column, I will use 2 milliliter of the 1 ppb solvent. So you see that like I'm taking 1, and the second one like 2 milliliter, like 1000 microliter. So one in the column, remember that it will go in the column. So here I'm making the solvent actually like from 5 ppb to 1 ppb. Now I'm gonna add the water and diluting it, and after that I'll add the 1 ppb solution in the column. So now I'm making the 1 ppb solution from the 5 ppb solution. So I'm diluting that part. Now I'm mixing it here. So how you can make 1 ppb from the 5 ppb? So you can take 1 milliliter of 5 ppb, and you can add 4 milliliter of water, so it will be 1 x ppb. So here I added like couple of milliliter because I know how much water I need to add. So ultimately I diluted that 5 pps solution to 1 pps solution, and once it is done and mixed, then I will use that 1 pps solution in the column, and then the column will be centrifuged again to remove the solvent, and by this way like 3 times will be done. And once it is done, then finally I will add the um, bioconjugated solution. So this is 1 pps, and now I'm gonna add um, those 1 pps solution in all of those java spin first round dried java spin desalting column, and each column will take 2 milliliter of this 1 pps solution, and that's what I am doing here. Now you can see here the solvent again taken out by centrifuge, so I will discard that solvent again, and by this way this will be done 3 times. So this will be the second time. So once those are done, then the same thing will be repeated. So here I transferred the bioconjugated solution after running 3 times 1x PBS solution, dried it, and then now I put those real bioconjugation solution here.
What?
Yeah.
Wait, what do you mean real?
Real means like what we did.
What we did. Okay.
That part now. Like
Okay.
first you have to do 3 times like washing with the 1x PBS.
Just one
The
XPPC.
column, yes.
Oh.
Column itself has some maybe the buffer
Uh-huh.
while it is stored, so we break the column, like you have to break down from the bottom and break it and put it there and run it and dry it out, and then put the 1x PBS part.
Oh, the column is inside here. Already.
Yeah, column is already inside, so 3 times. Now it is containing this bioconjugated product.
Do you have to fill the entire thing with one XCBS?
Not fill, like every time 1.5 for this size 1.5 milliliter.
Oh, okay.
1x PBS 3 times.
Okay.
And 3 times is done. Now I put the bioconjugation solution.
With the one XCBS?
No.
Oh no, you dumped that first.
Just take it out
And then you put in. Yeah. Okay. Cool.
yeah.
Oh, and you have to balance it out as usual.
Yes.
Right. Okay.
What is that, microliters?
Yeah.
Once column is dried, remove collection to okay.
Blot out the bottom? Okay. Oh yeah, how long?
That is 2 minutes.
At 1000
RCF.
Wait, that's RCF. What's RPM?
Rotation. No, this is different.
Oh.
Rotation something.
Yeah, I need to take a look at that. So this stuff is easier than yesterday, right?
Yeah.
The hardest part is the beginning, just setting it up. Okay.
So it is just basically filtration. That's it.
Filtration.
Filtration through the desalting column. That Java spin column is called desalting column.
So what are we getting rid of? Salts?
Salts and other things.
Oh, okay,
like
we have a lot.
small molecules will be stuck, and
yeah.
bigger protein molecule will come out.
So the
It's
protein
like
should
kind
be...
of GPC, gel permeable chromatography.
Mhm.
So GPC, like it has gel, so and the bigger molecule can go down quickly than
Yeah.
the small molecule. So small molecule will be stuck there,
Oh.
and like that is also the bigger molecule will come down first, and the small molecule will stuck there, and that's how it is getting separated. Like, so
So you're saying on the bottom
yeah,
is the stuff that you want in the tube still.
yeah.
Okay. Which one's which?
This is the BSA one.
Oh, what's in here? In these the bag? Just PBS?
Which one?
The ones they used to balance it out.
No, all are like,
Oh, did you split each one?
yeah.
Oh, okay.
So so this is should be bioconjugated part, and
Also, this is. Wait, what is this right here?
this is the main bioconjugated part.
Oh, you just transferred right now. Yeah. Wait, so since theoretically the bioconjugation has occurred already, so now we can do the centrifuge and we're no longer afraid of anything degrading or decomposing.
No.
Because yeah, before we wanted it slow, right? So now it's fine. Cool. No one needs to subscribe to this one. So now we're doing the MALDI prep. MALDI sample
So
prep.
multi-sample.
Yeah.
I'm going to take 5 microliter of where is that? HNK part, and I'll add 45 microliter 1x PBS to give the sample. So this is 5.
Wait, what is this? 5 microliters?
Yeah.
Okay. But this is just, you just don't need that much, right?
No.
Okay. 5 micro? This is so tiny. Is it even in there?
Yeah.
Oh my goodness. I hate working in small quantities. Can't see it.
CRM. So this. Oh. You know what? I could do another thing. Anyway.
I get paranoid.
Okay.
Oh, that's way more than 5 now, right?
Yeah.
What's this for?
Just diluting.
So what you're doing is transferring each sample and diluting it with 1x PBS.
5 microliter and diluting into 1x PBS for the MALDI sample.
How much PBS are you putting in?
1x PBS, 45.
45 microliters. Okay.
Yeah. Now we
Also, it's 50 total.
we also have to keep some amount of that CRM
See,
as a control. to
Oh,
see
just CRM. Yeah.
Same CRM we used for this.
Not bioconjugated, right?
Not bioconjugated. Yes.
Okay.
So let's see.
So that was I was showing like did the bioconjugation with the carboxylic acid group in presence of EDC. So carboxylic group has like the hapten means that part is like aromatic ring or like some other part. So in presence of EDC, basically it will react with the carboxylic group it to form the this carboxylic group will with the EDC it will form unstable reactive OSL urea ester, and once it form then it will react with that OSL urea ester will react with the sulfur and hydroxysuccinamide to give a semi-stable amine reactive NHS ester. So this EDs will be kicked out by this anhydroxysuccinamide group, and that is suitable for the amine conjugation. So that carrier protein has like lots of free amine group. Here you can see one amine group, but I am putting here n means like n number of amine groups. So ultimately that semi-stable amine reactive NHS ester will react with all of those amine group in the protein present, and ultimately it will produce like new amide bond. So the number of amide bond formed will be measured by the MALDI as a copy number. So this is the whole thing about the bioconjugation. I hope you will understand and you will be benefited, and if you have question ask me. Thank you.